We're going to look at factoring polynomials by grouping. Okay, now we're going to look at a very basic problem just to get the idea behind grouping so you can see how it works. And what I have set up here is if you had 2 tigers and you added 3 more tigers, you would end up with 5 tigers. Well, now the way we come up with this number 5 is we take our 2 and we add it to our 3, and then we keep our tigers. So we end up with 2 plus 3 tigers, which would be 5 tigers. So that's the idea behind grouping. We're going to be taking the items out in front and bringing them together into a set of parentheses. So go ahead and in your flip books put both of these examples in there if you have room. Otherwise, just put the first one in here. Now grouping is under our 4 term or more column. And as you can see here, we have 4 terms. And when I group, I want to put them together so that they have something in common that I can pull out. So if I look at these first 2 here, I could pull out an x squared out of each of them. And if I look at my last 2, I could pull out a -9 out of both of them. So I could group them that way. One way I would not want to group them, I would not want to put my x cubed with my 18 because there's nothing common that I can pull from those 2 items. So what I'm going to do is I am only going to focus on these first 2 terms to start with. And I'm going to look at what can I pull out. So out of these first 2, I can pull out an x squared. And when I do that, I would be left with x minus 2. Now the second 2, I'm going to pull out a -9 because I want this front one to be a positive number. Well, when I pull out a -9, I'm going to be left with x minus 2. Remember now when you pull a term out, you're actually doing division. So when I divide this term by -9, I'm left with x. When I divide 18 by -9, I'm left with -2. Now notice, here we have x minus 2 and x minus 2. This is like our tiger. So now I'm going to take my x squared and my -9 and bring them together. That would have been like the 2 and the 3 from the tiger problem. And then I'm going to bring my tiger label down, which is x minus 2. Now one way you can check to see if you're on the right track is go ahead and FOIL this back out. And if you do FOIL it back out, you will end up getting our x cubed minus 2x squared minus 9x plus 18. Now with grouping, most of the time you're not going to be done with one step. So as I look down at my 2 terms, I know that my x minus 2 factor is done because my exponent with the x is a 1. And whenever I get my exponent with the x to be 1, that term has to be done. But now my x squared minus 9, I still have an x squared in here that I may or may not have to deal with. So what I want to do is I want to check if I can factor this x squared minus 9 term. And hopefully you recognize that it's the difference of 2 squares, which is a shortcut in your factoring book. And it says if I have a squared minus b squared, which I do, I'm going to rewrite it as x squared and then 3 squared. I can factor that into x plus 3 and x minus 3. And then make sure you bring the x minus 2 down. Now as I look at all my terms, all of my x's only have an exponent of 1, so that would be completely factored. Notice we end up with 3 terms for this particular example. Hey, here's another one. Well, for my grouping, I'm going to, let's try putting those 2 together. I'm going to rewrite my equation so they're next to each other. So I'm going to have 2x cubed plus 2x minus x squared minus 1. The reason I decided to put these 2 together was because they each have a 2 and a 2x that I could pull out. And over here, when I put these 2 together, I can pull out that -1. Now this may or may not work. So let's go ahead and try this. Let's pull out a 2x from only these first 2. And when I do that for my front here, when I divide that by 2x, I'm going to be left with x squared. And when I take 2x divided by 2x, I'm going to be left with 1. Now on the back here, I'm going to pull out a -1 because I want this front one to be positive. So I'm going to pull out a -1, and when I do that, I'm going to be left with x squared plus 1. Now notice again, we've got the exact same expression inside our parentheses. This has to happen in order to use grouping. This is our tiger. If I didn't get the same thing, it'd be like trying to add tigers with giraffes. And you can't combine them like that. So now I pull out the 2x and the -1. I bring those together. That would be like the 3 and the 5 from that the tiger example. And then I tack on the tiger. Now notice, you only put the x squared plus 1 on here one time. When we had the tiger example, we had 2 tigers plus 3 tigers. Well, we didn't put tigers twice when we wrote our answer as 5 tigers. It was just one time. So we have 2x minus 1, and then we put our tiger, our x squared plus 1 here. Now I have to go and check if I can break it down any farther. Now my front term this time, the 2x minus 1, I know that's down as far as it can go because the x has an exponent of 1. But now I have to look at my x squared plus 1. And as I look at that, it's 2 terms. It doesn't follow that difference of 2 squares though because we have a plus sign here instead of a minus sign. So I can't break that one down any farther, which means that's as far as it can be factored. Okay, now here's 3 examples that you can use any method for. So go ahead and pause the video and see if you can use whatever method is appropriate for any of these 3. Okay, hopefully for this first one, you pulled out a common term first. It's going to make it much easier. I can see that out of the 32 and the 2, I can pull out a 2, but x to the 6th and x squared, I can pull out an x squared. So when I divide this by 2x squared, my 32 divided by 2 gives me a 16, and x to the 6th divided by x squared, well, if we use our quotient rules for exponents, I have to take 6 minus 2, so I would be left with x to the 4th. When I divide this one by 2x squared, that would cancel out and it'd become a 1. So I'm left with 16x to the 4th minus 1. Now I want to see if I can factor this binomial in here. And as I look at this, might be a little bit tricky because we have an x to the 4th here. Well, what you have to realize is this actually follows the difference of 2 squares. Because the 16 is a perfect square, so I can rewrite this as 4. And then you have to ask yourself, what can I square to get x to the 4th? Well, that would be an x squared. And then the 1 would just be 1 squared. So when I go to factor this one, I'm going to be left with 4x squared plus 1, following my pattern, 4x squared minus 1, and then that 2x squared comes down and hangs out front here. Then you have to go back and you have to look again to see if you can factor it any farther. The 2x squared I just leave alone because that's a monomial. It's all by itself. 4x squared plus 1. It has 2 terms, but it doesn't follow my difference of 2 squares because of that plus sign. So that part's done. The 4x squared minus 1, as you look at that one, that does follow your difference of 2 squares patterns. So we can break it down even farther. I'm just going to keep going to the side for this piece. The 4x squared would break down into 2x, that quantity squared, and the 1 would be 1 squared again. So this 4x squared is really going to be 2x plus 1 and 2x minus 1. So now when I'm all said and done, I've got an exponent of 1 here, so that term's done. I've got an exponent of 1 here, that term's done. The 4x squared plus 1 didn't follow any of our patterns, so it couldn't go any farther. And the 2x squared was a monomial, so it was done. So this example right here factors all the way down into 2x squared, 4x squared plus 1, and then 2x plus 1 and 2x minus 1. So that one, we had to factor it 1, 2, 3 different times in order to get our final answer. So what you have to realize is when you're factoring, you always have to keep checking if you can break it down even farther. Okay, I'm going to go ahead and erase this, and then we will try the second one here. Okay, this one is 4 terms, kind of a giveaway that you should probably use grouping. So I'm going to go ahead and leave them the way they are, because out of this front pair, I can pull out an x squared, and out of the back, I can pull out a -9. So it looks like it's probably going to work out pretty nicely. When I pull out an x squared, divide by x squared and divide by x squared, I'm going to be left with x plus 3. On the back group, I'm going to pull out a -9, so that's going to leave me with x plus 3 again. So divide both of those by -9, and that's where you get the x plus 3. Now notice I have the exact same matching thing here, so that's my tiger. I need to bring my x squared and my -9 together, and then I need to put the x plus 3 on the back. So grouping worked out in this one. Now I have to go back and check. This x squared minus 9, it's got an exponent of 2, so I have to check if it can be broke down farther, and it follows the difference of 2 squares again. So I'm going to rewrite it as x squared minus 3 squared. That way I can fill in my pattern a little easier. And that's going to be x plus 3 and x minus 3. So that x squared minus 9 turned into x plus 3, x minus 3. Now this x plus 3, I know I can't do anything to because its exponent with the x is 1. So that piece has to be done. Now as I look at all my terms, all of them have an exponent of 1, so I know they're done. This would be an acceptable answer, but do you notice how you have x plus 3 and x plus 3 here? We can actually write it just a little bit shorter, and we could write it as x plus 3 squared times x minus 3. So either one of these two answers would be okay. Okay, this last one might have been a little bit more difficult because it's the first time you've seen x's and y's in one problem, but we're going to treat it the same way. Well, I've got 4 terms, so that means I probably need to be doing grouping. I'm going to go ahead and leave these first 2 together. Most of the time with grouping, that you can leave the first 2 together and the last 2 together, and it will usually work out. So now these first 2, as I look for what's common between them, the only thing I can pull out is an x squared. When I divide my first term by x squared, I'm left with y squared. Divide my last term by x squared, I'm left with 3. Now in this back, I can pull out a -4. Remember, I always want this first one to be positive, so since there's a -4 in front of it, I want to pull that -4 out. So divide by -4 and divide by -4, and I'm going to be left with y squared minus 3. Notice again, we got y squared minus 3 and y squared minus 3. That's our tiger. So now I have to bring my x squared minus 4 together, and then my y squared minus 3. And I have to check to see if I can factor these any farther. The first one here, this x squared minus 4, follows that difference of 2 square patterns, so I'm going to rewrite it as x squared minus 2 squared, and then my pattern says it's going to be x plus 2 and x minus 2. Okay, my y squared minus 3 looks like it has potential to follow the difference of 2 squares, but it doesn't because 3 is not a perfect square. So we just get to leave that one as y squared minus 3. Then I go back, my x's are done, I decided I couldn't do my y squared minus 3, so that would be completely factored. Okay, here's 2 of them for you to try. You can use any method you want for these, and make sure you factor them as far as possible, because that might be 1 step or 2 steps or 3 steps that you have to do. So bring those with you to class.